Hello everyone. Next, we will learn the representation methods of cast-in-place concrete slab stair reinforcement detailing drawings. The components of cast-in-place concrete slab stairs include landing slabs, stair beams, stair columns, and tread segments. These components are represented in different ways in reinforcement detailing drawings, in plan. There are three representation methods for slab stair detailing drawings: plan annotation, section annotation, and schedule annotation. First, plan annotation. Plan annotation refers to indicating section dimensions and reinforcement details directly on the stair layout plan to represent the reinforcement detailing of stairs. This method includes centralized and peripheral annotations. For example, those shown in the diagram. First, centralized annotation. Centralized annotations for stairs includes 5 items. Specifically, 1. Stair slab type code and serial number, such as at 1. 2. Stair slab thickness, denoted as H equals value. For example, H equals 100, indicates the slab thickness is 100 mm. If the stair section includes a slab with a different thickness from the landing slab, indicate the landing slab thickness in parentheses after the stair slab thickness, starting with the capital letter P. 3. Total height of the tread segment and the number of steps should be separated by a slash. 4. Top and bottom longitudinal reinforcement of the stair slab at the support should be separated by a semicolon. Lastly, distribution reinforcement of the stair slab should be annotated with F, followed by specific values. This can also be explained collectively in the drawing. Second, peripheral annotation. Peripheral annotation includes the plan dimensions of the staircase, the floor elevation, interfloor elevation, the direction of the stairs, up or down, the geometric dimensions of the stair slab, the reinforcement of the landing slab, as well as reinforcement of the stair beams and stair columns, as shown in the diagram. All of these belong to peripheral annotations. Let's look at an example. H equals 130, P 150, indicates that the stair slab thickness is 130 mm, and the landing slab thickness is 150 mm. Another example in the plan view, a complete annotation of the stair slab type and reinforcement is shown as follows. At 1, H equals 120 indicates the stair slab type and code, with a thickness of 120 mm. 1800/12 indicates the total height of the tread segment is 1800 mm, with 12 steps. C10 at 200, C12 at 150, refer to the top longitudinal reinforcement and bottom longitudinal reinforcement, respectively. FE8 at 250 indicates the distribution reinforcement of the stair slab, which can also be stated collectively. Here is a term called distribution reinforcement, which is located inside the main reinforcement and arranged perpendicular to it. Its functions are to fix the position of the main reinforcement and to distribute the slab load to the main reinforcement. It also helps prevent cracks caused by concrete shrinkage and temperature changes in directions perpendicular to the main reinforcement. Additionally, for ATC-type stairs, the longitudinal reinforcement and stirrups of the edge beams on both sides of the stair slab should also be specified. The second method is the section annotation. Section annotation method requires drawing both the stair layout plan and the stair section view in the reinforcement detailing drawing. The annotations are divided into plan and section annotations. The plan annotation includes the plan dimensions of the staircase, floor elevation, interfloor elevation, staircase direction, up or down, geometric dimensions of the stair slab, type and number of stair slabs, the reinforcement of the landing slab, and the reinforcement of stair beams and columns. Section annotation includes the concentrated annotation of the stair slab, stair beam and column numbers, horizontal and vertical dimensions of stair slabs, floor elevation, interfloor elevation, and so on, as shown in the drawing annotations. The concentrated annotation for the stair slab includes 4 items, specifically 1. Stair slab type and number, such as at followed by a number. 2. Stair slab thickness, written as h equals value. When the stair slab consists of both tread segment and landing slab, and their thicknesses are different, the thickness of the landing slab can be indicated in parentheses after the stair slab thickness, starting with the letter P. 3. Stair slab reinforcement. The top and bottom longitudinal reinforcement of the stair slab should be specified with their reinforcement values, separated by a semicolon. 4. Stair slab distribution reinforcement, annotated starting with the letter F, followed by the specific values. This item can also be stated collectively in the drawing. 5. For at-type stairs, the longitudinal bars and stirrups of the edge beams on both sides of the stair slab must be indicated. Let's look at an example. In the plan view, a complete annotation of stair slab type and reinforcement is as follows. At 1, h equals 120 indicate the slab type and number, as well as the slab thickness. 1800/12 indicates the total height of the tread segment and the number of steps. The reinforcement section below specifies the top and bottom longitudinal reinforcement, separated by a semicolon. The annotation starting with F refers to the distribution reinforcement, which can also be explained collectively. For the section view, a complete annotation of the stair slab reinforcement is as follows. At 1, h equals 120 indicates the slab type, number, and thickness. C100 at 200. C120 at 150 represents top and bottom longitudinal reinforcement, respectively. The one starting with F refers to the distribution reinforcement of the stair slab, which can also be stated collectively. The third part, schedule annotation. The schedule annotation method presents the stair slab's cross-sectional dimensions and reinforcement values in a table format to express stair construction drawings. The specific requirements for schedule annotation are the same as those for section annotation, only the reinforcement annotation of the stair slab in the section annotation method needs to be replaced with a schedule annotation. The tabular form is shown in Table 7-2. Let's look at an example. The section annotation in the drawing can also be converted into the following schedule annotation. Let's compare the 3 standard stair drawing methods. First, the plan annotation method. It can present all stair-related information entirely within the plan view. This is the most commonly used and most straightforward method among the 3. However, due to the large amount of annotation content, the drawings produced using this method tend to be overloaded, resulting in complex layouts. 2. Section annotation method. This method uses section drawings as the base, clearly presenting the main stair components. The layout is clean and neat, and it intuitively reflects the reinforcement arrangement between floors. Although this method is intuitive, some annotations still cannot be fully conveyed in the drawing, and require additional supplementary notes. 3. Schedule annotation method. This is the most concise method, but it is the least used in actual projects, because the amount of information that can be conveyed in tabular form is limited, so it must be supplemented by other annotation methods. Though stair construction drawings seem simple, they require meticulous care and attention to detail from engineers, which is essential for ensuring overall construction quality. We must demonstrate craftsmanship in our drawings.